Bismillahir Rahmanir Rahim. Welcome to Cambridge Maths. Today we are going to solve a question from Probability and Statistics 1. And we are going to solve question number 6, which belongs to paper 9709/51 for the session May June 24. Let's read the question. The question says Harry has three coins. One coin is biased so that the probability of obtaining a head when it is thrown is one third. The second coin is biased so that the probability of obtaining a head when it is thrown is one fourth. And the third coin is biased so that the probability of obtaining a head when it is thrown is one fifth. Harry throws all three coins together. The random variable x is the number of heads he obtains. Question number A says draw up the probability distribution table for x. So first of all, before solving such question, we should not get confused ourselves. Usually we know that in probability distribution there are three major different kinds of probabilities, that is normal distribution, binomial distribution, or geometric distribution. Actually this such distribution cannot be categorized in any one of these three distributions. So what is the fourth option for us? Fourth option is we can solve it practically and applying our common sense. So let's see what are the cases. They have told each of the coins is biased, and for the first coin head, probability of head, let us write here head is equal to, for the first coin head is equal to, probability of head is what, one third. So if probability of head is one third, probability of t is going to be two third, isn't it? Means 1 minus p. So probability of the h of second coin is going to be, it is given one fourth, one fourth. Hence the probability of obtaining tail is going to be three fourth, one fourth, sorry, one fourth. So probability of having t is going to be three fourth. Then probability of h of the third coin, h, probability of head of the third coin is one fifth. So probability of obtaining tail is what, four fifth. Now as all three coins have been thrown together, so there are the possible cases. Let us see. After throwing all three together, there may be the possibility of having no tail, no heads. So if probability of obtaining no head, okay, probability of no head, that means if we don't obtain no head, means all three are tail, isn't it? So probability of first tail is 2 over 3, 2 over 3, as all three coins have been thrown together, so it must be multiplied. Okay, then probability of tail from the second coin is 3 over 4th, 3 over 4th. And so is for the third coin, whereas the probability of tail is 4 over 5. So ultimately our probability of obtaining no head, means obtaining all three tails, is 2 3 is 6 for 24 over 60. This is one of the possible cases. Let's see, if we throw all three coins, we may get only one head. X is the head, it is written here that x is the random variable x is the number of heads. Look, number of heads. So if there is only one head out of three, so what may be the possible cases? Suppose first one is having head, whereas second one and third one are tails. And the second possible case, first one is tail, second one is head, second one is head, and third one is again tail. So what is the third possible case? There may be first two are tails and third one is head. So these are the possible cases for obtaining only one head. So let us write this. If first one is head, probability is 1 over 3, and probability of tail of the second coin is 3 over 4, and probability of tail of the third coin is 4 over 5th. Plus, for the second case, if first one is tail, probability is 3 over 4, and second one is here head. If second one is, sorry, first one is tail, it is not 3 over 4, it is going to be 2 over 3. So let me erase this. So probability of first tail is 2 over 3, 2 over 3. Then probability of second head is 1 over 4, and probability of third tail is 4 over 5. Then the third possible case, in third possible case, first two are tails. So first probability of tail is 2 over 3, and probability of obtaining second tail is 3 over 4, 3 over 4 into 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 third one is head. So probability of obtaining third head is 1 over 5. Well, that's are the possible cases of obtaining one head out of all three. Okay, so let me just, yes. After that, let us simplify this. So 60 is always the denominator, and first numerator is 3 fours are 12, and second numerator is 2 fours are 8, third numerator is 3 2 2 3 and 1, so it is going to be 6. So ultimately our probability is going to be, if we divide 26 over 60, 26 over 60, if it is divided 24, so 26 divided by 60, using my calculator I get 0.433. This is the probability of the second case. Then let's move on to the third possible case. Okay, so for the third possible case, it is going to be, suppose there are two, there are what, two heads. Okay, probability of obtaining two heads when x is equal to 2. So two heads means, suppose the first one is head, second one is also head, third one is tail, or first one is head, second one is tail, third one is again head, or first one, first two are head, or first one is tail and third, second one and third one is head. So these are the possible cases for two heads. So let us write, if the first one is head, probability is 1/3, probability of second head is 3/4, sorry, 1/4, 1/4, and probability of third tail is 4/5, 4/5. Let me show you, it is 4/5. Look at this, here it is 4/5 of the tail of the third one. Well, so yes, so this is the first case, and second case is, first one is head. For the first head, probability is 1/3. For the second tail, probability is 3/4, and for the third head, probability is 1 over 5. So third possible case, first one is tail. So possibility of obtaining tail from the first tail is 2 over 3. And second one is head. Probability of obtaining head from the second coin is 1 over 4. And so is for the third one, 1 over 5. Well, so if we simplify, our LCM is going to be 60 every case actually, because the denominators are all the same. And numerator is 4 plus, let me erase, okay, 4 plus 4 plus 3 plus 2. So it is actually 9 over 60. 9 over 60 equal to 9 over 60. 9 over 60, let me do this division. 9 over 60 equal to 0.15. 0.15 is the probability of obtaining two heads. So the final case, if we get all three are heads, then what will be the probability? All three are head. X equal to 3. The x is the number of heads, so there are three heads. For three heads, actually it is H, H and H. Okay, all three are head, and there cannot be any other options for three heads, which is equal to first head is 1/3, second head is 1/4, and probability of third head is 1/5. Ultimately it is going to be 1 over 60 means 1 over 60 means what? If we divide 1 by 60, it is going to be 0.0167. So 0.0167 is the probability of obtaining three heads. Now we will have to write the final answer. All these three probabilities should be summed up. These were the cases for all probabilities. Now we require we will have to show the summed probability. Okay, so probability of, hence we can write, hence probability of, oh no, not probability, they have told us to write the probability distribution table. Okay, so let's draw the table. Will probability distribution table. Okay, we'll have to write it just over here, probability distribution table. Okay, so let us write over here probability distribution table. Probability distribution table. Okay, so let's draw the table. So what are the possible cases we have got here? X, this is X, and it is probability of X equal to X, that is small x, means number of heads. Okay, the probability of number of x. Okay, then if there is no head, means zero head, there might be one head, there might be two heads, and there might be three heads. Okay, three heads. So probability of first head, I mean no head, look at this, how much was the probability of first head? It was, if there was no head, then by doing this division, let me erase this. So finally if we divide 24 by 60, it is going to be 24 was zero point 0.4. This is 0.4. This is 0.4. And if we divide this 26, I mean by 60, it is 0.43. So let us just encircle them. This first probability is this. Second probability is this, third one is this, and fourth one is this. So let them be written. First probability is zero point 0.4. It is 0.4. Let me draw the table a little bit larger. That is our probability distribution table. Now we are going to insert our information. So probability of no heads is zero point 0.4. It is 0.4. Probability of one head is 0.433. 0.433. Let me zoom it out. It is going to be 0.433. 0.433. Point So 0.433, 0.433. And the third probability is when there are two heads, then probability is zero point 0.5, not zero point 0.5, it should be 0.15. 0.15, that means 4379 divided by 60. Yes, 9 divided by 60 is 0.15. This is not zero point 0.5, it is 0.15. So probability of obtaining two heads is 0.15, 0.15, and probability of obtaining three heads is nothing but 0.0, 0.016 and 7. That is what our probability distribution table is. So 0.4, 0.433, 0.15 and 0.0167. I think you have understood as far as I could have explained. Let's start solving the immediate next question. Question number B says, Harry has two other coins, each of which is biased, so that the probability of obtaining a head when it is thrown is P. He throws all five coins at the same time. The random variable y is the number of heads that he obtains. Given that probability of y equal to 0 equal to 6 into probability of y equal to 5. Okay, so y equal to 0 means actually there is no head, means all of them are tail, and total number of coins will be 5. Earlier there were 3, now here 2, and previously there were 3. And probability of each coin, remember here we should not get confused with this p is not the probability of both two coins together, it is probability of one coin. It is written loop, and so that the probability of obtaining a head when it is thrown a head, look, it is one head, not for both two heads. So there may arise a confusion that there are two coins, so it will be two, probability of two coins is p. No, it is probability of one head of the remaining or last two coins. He throws all five. Well, so already we have calculated the probability of three heads. Okay, now we will just include, I mean, as all of the five coins have been thrown together, it will be nothing but multiplication. So let's start our writing. Probability of when there is no head, probability of no head means y is equal to 0. Okay, now let me start from the given equation. What is the equation given? This is our equation. Look, equation is this. So let us write from this equation. What is the equation? Probability of y equal to 0, probability of y equal to 0 is equal to 6 into probability of y equal to 5. So what does 5 y equal to 5 means? All five coins show head, and y equal to 0 means there is no head. So if there is no head, what is the cases? For first three, let's go back to the previous page. For first three, if all three are tails, there is no heads at all, that means probability of 0 was what? Look at this, this is our probability of 0 means 24 over 60. So let us use this information. It is going to be 24 over 60. 24 over 60. This is the probability of obtaining no head from first three cases. What about the last two coins? For the last two coins, probability p is, for each one head, probability of obtaining each head is p. So t is going to be, I mean tail, probability of t is going to be 1 minus p, for total probability is 1. From 1, if the desired probability is subtracted, then that is the probability of the second outcomes. So probability of H is P and probability of tail is 1 over P. Now the question is, it is both of them are T. If there are two T's, what will happen? For one P, it is, for one tail, this is 1 minus P. As there are two tails, so it is 1 minus another P, isn't it? I think you have understood. H is equal to P, so H, let me write over here. If H, it is going to be P into P, means P square. If both of them are tail, then what will be the probability? It will be 1 minus P into 1 minus P, that is 1 minus P whole squared. 1 minus P whole squared. Let me just write over here. 1 minus P into 1 minus P for the first tail, 1 minus P. And if the second one is also tail, it is going to be 1 minus P. So ultimately it is going to be what? It is 1 minus P whole squared. So we can just insert this here, 1 minus P whole squared. So for obtaining both heads is P square, and for obtaining both tails is 1 minus P square. As there is no head at all, so it is going to be 1 minus P, 1 minus P whole squared. Let it be written 1 minus P whole squared, and we are going to erase this. Well, this is the case of if there is no head. Now what is the right part or right side of the equation? That there will be 6 into probability of all 5 heads. So first we will write the probability of 3 coins. If all 3 coins show head, what will it be? If all 3 are head, look at this, this is the probability. It was 1 over 60. So 1 over 60 for 3 heads, 1 over 60, it is 1 over 61 over 60. Then for the next 2 coins, further, as all of the 5 coins thrown together, so we will have to do multiplication. Remember, don't get confused that why are we not doing addition. All the 3 coins have been thrown together, that's why it should be multiplication. Okay, so for the first 3 heads it was 1 over 60. Now if for the last 2 heads, what will it be? If both of them are heads, it will be just P into P, means P squared. I think you have understood what I am going to try to explain. So once again, let me clarify this. How did we form the equation? Equation is for 5 heads, for no heads. First one, y is equal to 0, there is no head. So it will be just tail. Let me see. First tail, second tail, third tail, fourth tail, and fifth tail. For all 5 tails, there is for first 3. This is for first 3. For first 3 tails, there was 24 over 60. We have collected from the previous probability distribution table. Look at this. For all 3 heads, for all 3 tails, it was 24 over 60. So for 3 tails, we have written 24 over 60 into, as all of the coins have been thrown together, into for the next tails, next 2 tails. This is our next 2 tails. This is next 2 tails. So for next 1 tail, it is 1p. For 1 tail, that is 1 minus P. So for 2 tails, it will be 1 minus P into 1 minus P. That is 1 minus P whole square. Well, let's move on to the right side. In right side, it is given, 6 is given in the equation. This is given in the equation, that's 6. Okay, this 6 is in the equation. Then probability of all y5. That means all heads. Y equal to 5. So 1 head, 2 heads, 2 heads, 3 heads, 4 heads, and 5 heads. All of these are heads. Now these all are heads. Okay, for first 3 heads, we have extracted from the previous probability distribution table. If all 3 are head, look at this, the probability is 1 over 60. So we have written first 1 over 60 This 1 over 60 is for first three heads. Then for the next two heads, for each of the head of the next two coins, for each of the head, for each of the head of the next two coins, the probability is p. For one coin it is p, so for two coins it will be p square. So that is how we form the equation from the given expression. So let us solve this. From both sides, if we dissolve by 60, this 60 will go away. Okay, then what does remain there? It is 24 into 1 minus, if it is, if we apply the quadratic formula, I mean a minus b whole squared, so a square minus 2ab plus b squared. On the right side, it is going to be 6p squared. Well, now if we multiply this, 24p square minus 48p plus 24 minus 6p square, from the right side we are transposing it to the left side. Ultimately, what is it going to be? 24 minus 6, that is 18p square. 18p squared minus 48p plus 24. If we dissolve the whole expression, if we divide by 6, it is going to be, what is it going to be? It will be 3p squared. 3p squared minus 6 eights are 48 plus 4. Now if we factorize this, first of all we will expand this. If we expand 3 fours are 12, so 6 fours are 12. 3p square minus 6p minus 2p plus 4 is equal to 0. Now if we take 3p as common factor, so first factor is going to be p minus 2, and second factor is going to be 3p minus 2. Okay, 3p minus 2 is equal to 0. This is what the factored form of our quadratic equation. Hence our p is going to be, if it is 2, it is going to be 2 over 3. Now you may tell, why did we ignore this? Let me show. Since, because p equal to 2 is not a factor, probability can never be greater than, 1. So, or we can write in a inequality, probability is always, as there are two sides of this coin. Look at this. It is about, p was the what? P was the probability of h, isn't it? Probability of h. Probability of h is, head is p. So if there are two possible cases, head and tail, one is p, another one is 1 minus p. So total it can never be more than 1 or less than 0. It cannot be even 1, because if there are two possible cases and it is biased, so how can p obtain as 1 even? It cannot be even 1 also, because either it will be head or tail. There are only two possible cases. So one only head cannot be 1, nor tail can be 1. That's why it is less than actually 1. P is less than 1. But for general case we can write p will be either 0 until 1. Okay, it will be less than or equal to 1, or more than or equal to 0. Hence our probability is p equal to 2 over 3. I think you were attentive while I explaining whole of this solution, and that is what the total solution is. If it benefits you in the least bit, then I will be grateful to Almighty Allah. Alhamdulillah. So thank you all for watching the video. We will talk with each other in the next videos, inshallah. And for any complication or any difficulty you face, you can please knock at me through the WhatsApp number I provided with as the description box of my channel name. Fi amanillah.